Today we're going to it looks like we're going backwards to section 8.2. That's because typically you do that after looking at quadratics in standard form like we did last time, y equals ax squared plus bx plus c. So now in section 8.2, we're going to look at our quadratic functions, but we're going to look at them in standard form. Or sorry, not in standard form, in vertex form. So when you look over here, it shows us that the general form for vertex is y equals a parentheses x minus h close parentheses squared plus k, right? So if we go back before, we said that standard was y equals ax squared plus bx plus c. Okay, so this is called standard form, and that was in section 8.3. And again, that's typically what you do first, so that's why we did that first. So that was in section 8.3. So now we're looking at 8.2. We're looking at a different form. These are still quadratics, they're parabolas. We see that quantity squared, right? So it's a little bit different. Notice before we had the variables that represented coefficients and constants. We had a, b, and c. But notice that when we're looking at this quadratic in vertex form, we still have a, right, in front of the parentheses. But then we have h and k. So those variables, because it's in a different form, represent something different, because now we're looking at vertex form. So let's see what they mean and what they do. So the cool thing about vertex form is that when you look at the equation, you can easily see the vertex, and you don't have to do negative b over 2a to find the x coordinate. You just write h comma k. And because the x coordinate of the vertex is also the axis of symmetry, that's why you would say x equals, whatever is that h value. So I know it can be confusing when you don't actually see numbers. So let's take a look. Let's look at the first one that they give us. So if we identify all of the parts, right? If we say the general equation says y equals a times x minus h parentheses squared plus k, right? Then we're looking for what aligns. So in the a spot, a would be -2. In the h slot, that's going to be a +1, right? The x's align, the minuses align, so the h value is a 1. And then the k is the number off on the right, so it's 3. Okay, so for this problem, we know that our a value is -2, our h value is 1, right? Because the formula again says x, so those would cancel, minus, so those would cancel, so what's left is our h, which is a 1. And k is the number off on the right, and our number off on the right is +3. So sometimes people really struggle with the h value, so just be careful with your h, okay? H is the one that sometimes people mess up on. Okay, so the formula says that the vertex is always h comma k. So if you look at this problem, if we've identified h as 1, then you'd write 1 comma k, whatever your k is. And if we said k was 3, we would say 3, right? H comma k. So our vertex, right, is 1 comma 3. And again, that's because your vertex is h value comma k value. So if we said the h value was 1, that number goes in this spot, in the x coordinate spot. And if we said the k value was a 3, we will put the 3 in the k spot. That's why we had 1 comma 3. So our vertex is 1 comma 3. The axis of symmetry is the x coordinate of the vertex. So if you look at the vertex, the x value is 1, so that's why you say x equals 1. Remember, axis of symmetry is a vertical line, okay? Vertical lines, think hoi vux, right? Vertical lines are x equal some number. So you don't just want to write a number, you want to say x equals. So x equals 1 because the x coordinate of the vertex is 1. Okay. Now if we look over here, we see that the vertex is at 1, 3. All right. To the right 1, up 3. So that's the vertex. We see that that axis of symmetry is x equals 1, right? Slices through x equals 1. So our axis of symmetry. This was our vertex. And then we can look at this graph too, and because that a value in front was -2, right? Because the a value was -2. Just like before, like we learned the other day, if the a value, because our a value is negative, we know our graph should be upside down, right? Which this graph is, in red, it's upside down. And then we look at the absolute value of -2, and we know that's 2. And since 2 is greater than 1, we know that it's going to be a opposite of intuition, so bigger means it's actually going to become narrower than our parent. So that's just like last time. Negative means upside down. You say the absolute value because positive, negative is just direction. So the absolute value is 2. So it's upside down, and we're stretching it so it becomes narrower. Okay? And we're saying narrower than the parent function. So all we're going to do today, we're going to start going slowly and just identifying the vertex axis of symmetry up, down, and saying narrower, wider compared to parent. That's it for today. Then later we'll practice, plotting some points, drawing the picture of the graph, turning this back into standard form, and so on and so forth. Now, I'm going to do the odds, and you're going to do the evens for homework. So together we're going to do 29, 31, 33, and 35. Okay? Whatever I don't finish here, you'll watch in the next video. So the vertex for this first one, I'm going to see if I can just write in here. Maybe text, insert, text box. Okay. So let me see if I can put that right here. So in here, we're going to have our vertex. Okay, I'm just going to delete that. It doesn't look good. So I know my vertex is like this. We know it's H, K. Okay. Now when we look at number 29, this one's a little bit tricky for people. When we look at number 29, a lot of people get part of it right, but they struggle with some of the stuff. So A is the number in front, right? So A for 29, A is 2, H and K. K is 4, so A is the number in front, 2. K is 4. H is actually, I'm going to do it in a different color. It's opposite of what you think. It's -1. Okay? And the reason for that is because if we look at this equation, the general equation says A times X minus H squared plus K. So you notice, okay, the A's align, those are 2. The K aligns with the 4. However, right here, the X's align, but then there's a positive sign and a negative sign here, and those don't align. So you can rewrite it. There's a few ways of looking at this. You can rewrite it so that it aligns with the general equation that says y equals a times x minus h squared plus k. And so when I write this equation below, I'll go, okay, 2x. Now if I want this to align, I'm going to put a negative here, and then negative 1 plus 4. So do you see why I did that? I played around with this, and right in here sometimes you have to change the signs so that it aligns. We know that this is still x plus 1, like the problem says, right? But I turned it into double negatives so that I could figure out what a, h, and k are. So a aligns, so a is 2, right? The k is the number at the end, so k is 4. If it was positive 4, it's 4. If it was negative 4, it would be negative 4. Now the x's we cross off. The negatives we can cancel, so the h value is what's left. So that's why in this case h is negative 1. Okay, and k is 4. So our vertex, going back to this, our vertex is h comma k, or negative 1 comma 4. Our axis of symmetry is x equals h. And we just say that because that's the x coordinate of the vertex. And it slices through, so it's x is negative 1 is our axis of symmetry. The graph points up because a is positive 2. And because the absolute value of a is bigger than 1, we know our graph is going to be narrower than the parent function. Okay. Now, I'm going to show you in the next video. I like to honestly just do, when I look at the vertex, I don't like to rewrite all of this. Literally all I say is the vertex is opposite of inside number on right. So if it's like a positive 1, I say negative 1, comma, number on right, 4. Okay? So I say opposite of what's inside the parentheses. So opposite of positive 1 is negative 1, comma, number on right, 4. Again, opposite of inside would be negative 1, comma, number on right, 4. So that's the vertex. This one we looked at before where the vertex was 1, 3. If you look at the original problem, it says negative 2, parentheses, x minus 1, parentheses, squared plus 1. Vertex, opposite of inside, number on the right. So opposite of inside, opposite of negative 1 is 1. Check. Comma, number on right. Comma, positive 3. So vertex, opposite of inside, number on the right. Everything else is literal. A is the number in front of the parentheses. K is the number behind. So if the number behind is positive, the k value is positive. If the number behind the parentheses is negative, your k value is negative. Only thing that's funky is your vertex. Opposite of inside, number on the right. So again, for the original example, opposite of negative 1 was 1, comma, number on the right was 3. So our vertex was at 1, 3. Your axis of symmetry is the x coordinate of the vertex, so it's x equals 1. 29. Vertex, opposite of inside, number on the right. So negative 1, comma, 4. Axis of symmetry, x part of vertex, so x equals negative 1. Direction, you look at the A. The number in front is a 2. Positive 2 is up. Absolute value of 2 is 2. If you're always comparing to 1 for the parent, it's greater than 1, so it's opposite of intuition. It's actually a narrower graph. Okay, we'll do the others in another video.